Algebra 2 students, we're starting Unit 6 and we're going to talk about properties of exponents today. So when I want to multiply two bases that have the same power, there's an interesting rule that applies, and we're going to figure that out right here. If I have a to the fifth, that means a times a times a times a times a. That's a to the fifth. If I have a squared, that's just a times a. So now, if you look to see how many a's you have 7 altogether, so this is equal to a to the 7th. Okay, let's do the same thing with the x's. If I have x to the 7, that literally means x as a factor 7 times. Okay, so there's x to the 7th. I have one more x, so times one more x. And now altogether, I have x to the 8th. So you can see when you multiply two powers with the same base, you end up actually adding the exponents. A to the 5th times a squared, when you map it all out, you see you get a to the 7th, and 5 plus 2 is 7. So that's the rule. When you multiply, you add exponents. Power of a power. So I have a to the 5th, and then I want to raise that whole thing to the second power. So a to the 5th would be a times a times a times a times a. That's a to the 5th. When you square something, you multiply it by itself, so I have another one of those. A times a times a times a times a. So a to the 5th, and then I square the whole thing, so I multiply it by itself, and now I have 10 a's altogether, so I have a to the 10th. Okay, x squared is my inside, that's x times x. And that's raised to the 4th power, so that means that this is a factor 4 times. So I need 4 of them. 1, 2, 3, 4. And inside each one is x squared. Okay, so all together now you see I have x to the 8th. So if I have 5 and 2, it gives me 10. I have 2 and 4, it gives me 8. Then your rule is to multiply the exponents. Okay, and this is called power of a product. It's very similar to power of a power. It's just that there's more going on inside the parentheses. So a squared times b. A squared is a times a, and then times b. That's the inside. And that happens 5 times, so I need 5 of those. A, B. A, B. Alright, so I have 5 AABs. Now I need to figure out how many of each I have. So of the A's, I have 2, 4, 6, 8, 10. So I have a to the 10. And how many B's do I have? 1, 2, 3, 4, 5. B to the 5th. So a to the 10th, b to the 5th. Alright, next one I have x to the 3rd, y to the 4th. So x to the 3rd is x, x, x. Y to the 4th is y, 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 y. And then that's squared, so it's multiplied by itself. X, 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 y, 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 y. So altogether I have x as a factor 6 times and y as a factor 8 times. So to find the power of a product, you blank each exponent by the outside exponent. So if you look at the first one, a squared to the 5th became a to the 10th, b to the 1st to the 5th became b to the 5th. In the second one, x to the 3rd squared became x to the 6th, y to the 4th squared became y to the 8th. So you can see you end up multiplying the outside exponent times each of the inside exponents. Okay. For a negative exponent, what you end up doing is taking the reciprocal, so that if I have a to the negative 2, that equals 1 over a squared. If you have two factors, x and y, you only take the reciprocal of the part with the negative exponent. The other part will stay in the numerator. So the y squared stays in the numerator, but the x to the third, because that's the part with the negative exponent, that goes to the denominator. So if you have a negative exponent, that term becomes its reciprocal. Alright, anything to the 0 power is 1. Doesn't matter how big it is. If you want to have 2,345,678 and you raise it to the 0 power, it's still 1. So any base to the 0 exponent is 1. Okay, let's look at quotients. If I have a to the 5th divided by a squared, I'm going to write that out. A to the 5th is a squared is a times a. So you can see these a's cancel out and these a's cancel out, and I'm left with a to the 3rd. For the x's now, I have x squared on the top, and I have x to the 5th on the bottom. Okay, so I can see these cancel, and I have x to the 3rd, but notice it's in the denominator. So that's going to be 1 over x to the 3rd. So you can see 5 and 2 gives me 3. 5 and 2 gives me 3. It's just where your exponent is larger, that's where your answer ends up. So in the first one, the larger exponent's on the numerator, so your answer is in the numerator. And in the second one, the larger exponent's in the denominator, so your answer is in the denominator. And you end up subtracting your exponents when it's a division problem. Alright, so here are some practice problems. You should pause the video and try the practice problems before checking your answers. Okay, in the first one, I have an x here, so I'm going to make that x to the 1. It's a multiplication problem, so I'm going to add the exponents. So x to the 3 times x to the 1 gives me x to the 4. Y to the 9 times y to the 3 gives me y to the 12. And I'm going to check, is it either of these? No. Okay. Here's a division. The bigger exponent's on the bottom, so when I do 7 minus 1 and I get x to the 6, that is in the denominator. So that's neither of these either. Power to a power, you multiply the exponents and you get x to the 8th. Okay, still not matching any of these answers. Here's a multiplication problem. You add your exponents, I get x to the 8th again. This one's a division problem. When I divide, I subtract my exponents. 10 minus 4 gives me x to the 6th. So that's one of these answers. I'm going to put x to the 10 over x to the 4 in this box. Alright, second row. That x is going to be x to the 1. That x is going to be x to the 1. So when I multiply them, I'm going to get x squared. And when I multiply y squared times y to the 4th, you're going to add them again, and you get y to the 6th. So that's this answer over here, so I can put that one over here. X y squared times x y to the 4th. Alright, next one's a division problem. This x doesn't have an exponent, so I give it a 1. And now I'm going to subtract 3 minus 1, and I get x squared. And 8 minus 2 gives me y to the 6th. So that's also x squared y to the 6th, so I'm going to put that one here. X to the 3rd, y to the 8th, over x, y squared. Alright, next one. Power to a power, so you raise each of these to the second power. So x squared. And I have y to the 3rd to the 2nd. So power to a power, you multiply and you get y to the 6th. So that's another one for this answer. X squared, y to the 3rd, and squared. So I had 3. Alright, next one, when you multiply, you add exponents, so you get x to the 6th, and that's over here, so I'm going to put that over here. X squared, x to the 4th. And the last one is power to a power, multiply your exponents, and you get another x to the 6th. So that's x to the 3rd squared. Okay, next page. Alright, here we're trying to make the answer x to the sixth. So the first problem is a multiplication problem. When you multiply, you add your exponents. So I'm thinking 2 plus what number gives me 6? 2 plus 4 equals 6. So this is x to the fourth. Alright, another multiplication problem. You're going to add your exponents. So 1 plus what equals 6? 1 plus 5 equals 6, so this is x to the fifth. Alright, these two are division problems. When you divide, you subtract exponents. So 12 minus what equals 6? That's going to be 6. Alright, and then this time I have x to the 1 in the denominator. So what number minus 1 equals 6? That would be 7. So this is x to the seventh. Okay, this is a power to a power problem, so I'm going to multiply my exponent. So what number times 3 gives me 6? This one. 2 times 3 is 6. And the last one is something we haven't done yet. This is adding. When you add, you do not change your exponent. But I'm going to add my coefficient. So I want my answer coefficient to be 1. So negative 2 plus what number gives me 1? That number's 3. So I have 3x to the sixth. Alright, so these are practice problems. You should pause the video and then just watch to check your answers. In this section we're using numbers instead of variables, but you use the same properties. It is possible to do these problems on a calculator, but it's good practice to do them without the calculator. You could always use a calculator to check your answers. For the first one, it's a multiplication problem, so you add the exponents, and I get 4 plus negative 2 is 2, and 3 squared is 9. 3 times 3 is 9. Next one is power to a power, so I'm going to get 5 to the sixth. And that one you probably do need a calculator for because it's 5 times 5 times 5 times 5 times 5 times 5, which is pretty big. It ends up being 15,625. Alright, the next one is the power of a quotient. So you end up taking that 3 and distributing it to the 2 and the 3. So you get 2 to the third over 3 to the third. 2 to the third is 2 times 2 times 2, which is 8. 3 to the third is 3 times 3 times 3, which is 27. Alright, next one. I have the bigger exponent on the bottom. 6 minus 4 gives me 2. So I have the 8 squared in the denominator, and that 8 squared is 8 times 8, so I get 1 over 64. Here's a multiplication problem, and I'm going to add the exponent. 6 plus negative 6 is 0. So 7 to the 0 is 1. Alright, problem 6 is a multi-step problem. I'm going to put a 1 because this doesn't have an exponent. So when I multiply, I add those exponents and I get 4 to the fourth. And then I have 4 to the sixth. And my bigger exponent's in the denominator, so 6 minus 4 is 2. I have 1 over 4 squared. 4 squared is 4 times 4, which is 16, so I have 1 over 16. Alright, in problem 7, these are also going to be multi-step problems. First I do power to a power, so I multiply 2 times 5. I get 3 to the 10 over 3 to the 8. Now I'm going to subtract the exponents. I get 3 squared, which is 9. When you have a negative exponent, you want to take the reciprocal of the base, so the 1/2 becomes 2, and that makes your exponent positive. So I have 2 to the fourth, 2 times 2 times 2 times 2, and that's going to give you 16. In problem 9, I'm going to do power to a power first, so multiply those exponents. I get 5 to the 6 over 5 to the 6. When you subtract those, you get 0, so 5 to the 0, and remember anything to the 0 is 1. Alright, we're going back to variables. Well, with variables, the calculator is not very helpful, so you have to remember your rules. Multiplying, you're going to add exponents, you get x to the fifth. Dividing, you're going to subtract exponents. So the bigger one's on the bottom, y to the 5th minus the 3rd is going to give you y squared in the denominator. But that 2 does not have an exponent, it stays where it is on the numerator. For problem 12, distribute the squared to each of these, so you'll get 3 squared x squared. And 3 squared is 3 times 3, which is 9, so 9x squared. Okay, next row. Distribute that 3 to the y and the 2. You get y to the 3rd over 2 to the 3rd. And y to the 3rd stays. 2 to the 3rd we know is 8. In 14, we distribute the 4 to each of these, so I get 4 to the 4th, and then I multiply the 3 times the 4, and I get x to the 12th. 4 to the 4th is 4 times 4 times 4 times 4, which is 256. X to the 12th. Okay, in 15, x to the 0 is 1. And y to the negative 2, I need the reciprocal, 1 over y squared. So 1 times 1 over y squared is just 1 over y squared. Okay, last row. In 16, the 5 over 2 does not simplify. Remember, these are numbers, not exponents, so don't subtract the 5 and the 2. Leave that be. Two is bigger than negative 1, so I'm going to put my answer here on the top, but think about what is 2 minus negative 1. Minus negative is positive, so that's 3. That gives me x to the 3. And for the y's, the bigger exponent is on the denominator, so 3 minus 1 gives you y squared. Okay, negative 3 over 9, that fraction can simplify. Negative 3 over 9. Dividing them both by 3, you get negative 1/3. Alright, for the x's, 3 minus 1 gives you x squared in your denominator. And here's a y to the 1. So 1 is bigger than negative 4. Think about 1 minus negative 4 is 1 plus 4. So that gives you y to the 5th in your numerator. Okay, last one, we're going to distribute the squared to each of these. So you get 3 squared x squared over 6 x to the 5th. 3 squared is 9, so 9x squared over 6x to the 5th. Okay, 9/6 simplifies because they can both be divided by 3. So 9 divided by 3 is 3. 6 divided by 3 is 2. Your bigger exponent is in the denominator, so you're going to do 5 minus 2, and you get x to the 3rd in your denominator. In the last section, you should see how many expressions you can write that will simplify to x to the 3rd. See if you can get some examples with each operation, a multiplication example, a division example, a power to a power example, and maybe a more complicated example. Alright, that's the end of your video. Keep working on your challenge.